All right, so question 8, tangent. We don't necessarily know a nice, easy antiderivative or something that has a derivative of tangent. So what could we do? Who knows? So one thing we could do is we could rewrite the tangent as the sine of x over the cosine of x using our trig identities. And then when we write it like this, well, now things start to fall into place because we see that we have a sine, which has a derivative of cosine. We see that we have a cosine, which is kind of a derivative of sine. Those things are derivatives of each other. So we can make a u substitution here. So there's kind of two different ways that you can go, and one way is a lot better than the other. If you said u was sine of x, then du would be cosine of x dx, right? And the problem now is if you, again, solve for dx, you would get du over the cosine of x. So when we made our u substitution, we get u over the cosine of x times du over the cosine of x, and we haven't gotten rid of our x's here. So rather than making u the sine of x, let's flip them. Let's make u the cosine of x. If you make u the cosine of x, the derivative is negative sine dx, right? And so that is what we have here in the numerator. So if we make that u substitution, we would get negative du over u, which we'll see a lot. So it's kind of good to get used to it, but it kind of can also help if you pull the negative out and think of this as 1 over u du, because then it's a little bit clearer that we're working with a natural log. Negative natural log, absolute value of u plus a constant. So negative natural log of the absolute value of cosine of x plus a constant, right? And notice here it is important to keep our absolute values because the cosine does dip into negatives an infinite number of times.